right, so example 5, we have 1 over 6 minus 1 over 6n is equal to n squared minus 2n minus 15. All right, so LCD here is pretty simple. It's just the 6n squared. So when we go through and multiply each term by the 6n squared, it cancels in the last one, it cancels in the middle one, and the 6 cancels in the first one. So we're left with n squared minus, you can't lose this. Normally we don't need the 1, but if everything cancels, you need that 1. Okay, usually we just kind of neglect it. Like in the first case, it was 1 times n squared. That's why we kind of ignored it, because 1 times n squared just gives you n squared. But here, the 6n squared cancel, so you can't just drop that 1. You've got to keep it there. And then that is equal to the 6n squares cancel, so it's n squared minus 2n minus 15. Notice I dropped the parentheses because it's not being multiplied by anything. There's not a negative in front. Okay, so this looks like your quadratic equation. The ones that we've done so far have all been linear. It looks quadratic, so if it's a quadratic, it must be equal to 0 before we can solve. So I'm going to try and get that quadratic n squared on one side, so I need to subtract it. Well, when I subtract it, it actually ends up canceling from both sides. So it looked like it was going to be a quadratic equation, but it's not. It's really just another linear equation. Okay, so let's add the 15 to both sides. So we get 14 is equal to negative 2n. Divide by negative 2. So we get n is equal to negative 7. I'm not going to take the time to plug that one back in, but just remember, you always should. Okay, let's look at another one similar to that. Number 6. Okay, same kind of deal with the denominators there. Pretty easy LCD. It's just the 2k squared that will eliminate our denominators properly. So it completely cancels for the last term on the right side. The k squared cancels in the first and the second terms. So we've got 1 times 2. So we've got 2 minus, I'm going to put that 2 in front of my parentheses, the k squared minus 25, because it's going to be a constant that I distribute. And then the 2k squares canceled, so I just bring down the k minus 3. Okay, I'm going to distribute a negative 2. That's the easiest way to handle that, is to just go ahead and consider that to be a negative 2. So we've got negative 2k squared plus 50. Negative 2 times negative 25 is positive 50, is equal to k minus 3. Now this one is definitely a quadratic equation because we've got a k squared and it only shows up once. Now usually I would move everything to be on the same side as the k squared, but my k squared is negative, so I'm actually going to move that to the other side so that it'll be positive. So it was negative, so I add it. And let's see here, we've really got 52 on this side, so I'm going to subtract the 52 so that everything is on the 2 plus 50 is where I'm getting 52. I want everything on the right side, and I want to write it in standard form. So 2k squared first plus k minus 55. All right, it's a quadratic. It's equal to 0, so now we can factor. It must be equal to 0 before you can factor. I will repeat that again. It must be equal to 0 before you can factor. 2k times k is 2k squared. Factors of 55. I'm thinking 5 and 11. Yes, I know 5 and 11 do not add to give me 1, but don't forget, one of them is going to get multiplied by 2. So we've got 10K and 11K. We need positive K, so we need the 11 to be positive and the 10 to be negative. So 2K plus 11 and K minus 5. So now we take both of those and set them equal to 0 and solve them individually. Okay, so we get negative 11 over 2, and we get positive 5. Now this is where it's non-negotiable. You have to check your solutions when there are 2 of them, because in a lot of cases, not always, but in a lot of cases, 1 out of the 2 will not actually work as a solution. So you must check both solutions when you get 2 with these equations. So let's check these really quick. Store negative 11 over 2 as x and plug it in. 1 over x squared. You can put parentheses there. You really don't have to have parentheses. I'll go ahead and put them just so we're in the habit. It never hurts to have them unless you just don't put them in the right place. And that'll mess you up. Okay, so 1 over x squared minus 25 over x squared. Okay, so that's the left side, right side. Now you do have to have them with the 2x squared. So left side and right side check out. They equal the same thing, so 11 over 2 is good. Let me save you some time and effort right here. Store 5 as x, but don't start typing in all that stuff all over again. If you don't know about this, you need to know. Press second enter and keep pressing that until you get back to that line that you typed in about 3 entries ago. Okay, that was the left side of our equation. And then the right side, press second enter, just keep doing it until you get back to the right side of your equation. That way you don't have to type all that stuff in again. Especially if the first one checked out, you know that you had your parentheses and everything in the right place. So why worry about having to type it in again? 5 also checks out. Okay, so we can have 2 solutions. Both of them can work out. In several cases, though, one of them will end up getting thrown out for some reason. So you have to check your solutions when you have to. Any questions about this process in number 6 anywhere along the way? I didn't really pause much there. Any questions?